So if I'm running OSPF and ISIS, then ISIS will be preferred. OSPF will be preferred, na? Because OSPF AD value is 110, ISIS is value 115. OSPF will be preferred. Now we know that router decides the best path on the basis of AD value. Correct? Now let's do some test once again. BGP having two AD values. There is a two kind of BGP neighborship. One is EBGP, another is IBGP. For EBGP neighborship is 20, IBGP neighborship is 200. When we discuss the BGP class, right, that BGP class is there for 2 days. At that time, I will let you know about the details. IGRP is no more you into the production. You can forget about that. No, not. So, what is the criteria for the router to select the best path? Sorry, best path, best routing table. What is the criteria to select the best path for the router? Smallest AD value. Then what is the criteria to select the best routing protocol? You guys are not understanding the statement. I am saying best path, I am saying best routing protocol.
Best routing protocol is AD value.
What about the best path? Okay, come. So now we know that we have the range from 0 to 255. Out of that, lower will be preferred. The AD value, the routing protocol which has the lower value, router will prefer that routing protocol on the basis of AD value, right? So routing protocol. Routing protocol selection based on the AD value. AD means what? Administrative distance. That is the trustworthy toward router. Means if I have the lower value, if a router has the lower value, the router will trust on the protocol more as compared to the higher AD value, right? So that is on the basis of AD value. Routing path selection based on question mark. Based on matrix. This is on the basis of matrix. No worries. So in each routing protocol, when we get the output over the router, we have the two things. One is administrative AD value, then slash notation, then matrix. So that matrix is basically deciding the best path selection criteria. Routing protocol, AD value. Best path selection criteria, matrix, right? So let's come to the diagram once again. Where is the diagram? Okay, let's do some modification into the diagram. R1, R2, R3, R4, R5. And here, let's suppose network is 192.168, 1.0/24. So I'm writing just 1.0/24. 192.168.1.0/24, 192.168.2.0/24, 192.168, 3.0/24, 192.168.4.0/24, 192.168.5.0/24. Right? So RIP. AD value for RIP is right, and the matrix for AD value, the matrix depends on the hop count. Hop is number of the router. In the path from one destination to another destination, how many router equal to hop. So in the RIP actually we don't call router, we call as a hop. So how many hops are there into the path from source to destination? From source R1 to destination R4. How many paths are there? How many paths? Two paths. One is from this and one is from this. So I have a two paths to reach to the destination. So I am saying when we go from one router to another router, when we go from source to destination, we count the hop. Hop is equal to router. So we count basically we count the router, but in the RIP the technical word is hop. So hop count. So for RIP matrix is hop count. Hop equal to router. So from R1 to R2, from R1 to R4, I have one path. So from this is the source and this is the destination. So the first router, first hop, second hop. So from R1 to R4, I have a two path. One is via R1 to R2, then R3, then R1 to R2, R5, then R3, then R4. But this is your source IP, source, and this is destination. This is source, this is destination. So in between the path, from the upper path, I have one router here, another is here. If from the lower path, I have one router here, and one router here. So from the upper path, I have the two hops. From the lower path, I have the three hops. Right? Here also lower will be preferred. So which one will be preferred? Upper path. So that is the criteria for OSP. Sorry, RIP. Matrix is the criteria to select the best routing path, and that depends on the hop count. The path where we have the less hop count, that path will be preferred over the path where we have the higher hop count. So I have the two paths, one is from upper side and one is from down side. So from upper side I have the two hops, and from the down side I have the three hops. So the hop with the lower, it will be preferred over the higher into the RIP routing protocol. Clear? So this is the criteria for RIP routing protocol. Okay? So if I talk about the RIP routing protocol, so the best path would be from R1 to R2, then R3 to R4. Right? So all the traffic for RIP routing protocol, all the traffic will go by upper path. What if this link goes down? If that link goes down, router will remove the best path from the routing table. Which best path? From the two hop, and it will install the second best path from the lower side. From the lower side, it will install into the routing table, and all the traffic will start going through R1, R2, R5, R3, and R4. When an upper path comes up, let's suppose we have some fault into the link, right? Link, and it comes out after some time. Then again routing table will get converged, and the best path will come into the routing table. So this path will be the path where we have the three hop, it will get removed, and the path where we have the two hop, again it will come into the routing table in case of automatically, no need to do anything. This is what that is why we call it a dynamic routing protocol. We need to enable the protocol first. First of all, we need to enable the protocol, then forget about it. There is a I don't remember actually. R1 to R4. If my R1 is here and R4 is somewhere in Bangalore, can you connect directly? This is a diagram, yeah. This is the diagram. In the diagram, you can do anything. But in the real time, tell me one thing: if R1 is here, R4 is in somewhere in Bangalore or Pune, can you lay a cable from R1 to R4?
Cable you can't, but routing between them connect.
Routing, but R1, R2 is a PC. Consider as a PC. So PC will go to the gateway. Where is the gateway? From R1 point of view, gateway is R2. From R4 point of view, gateway is R3. Right? So you have to reach the gateway first. Then gateway will perform the routing. Right? The RIP is clear. What is the best path selection criteria for RIP? Best path selection criteria. Opcom. What is the best routing protocol selection criteria? AD, right? So this is the RIP, right? So in the RIP, if we are running a RIP routing protocol over the router, then it will select the best path on the basis of hop count. If you are running a two protocol, RIP and OSPF, then OSPF will be preferred over the RIP because of the AD value, right? Then what about the OSPF? See, for OSPF actually we have the dedicated class. Here core class is to take for OSPF. So just a basic overview, why we are having this, why we have the disadvantage when we run the different routing protocol. OSPF will also help you to reach to the destination. RIP is also helping you to reach to the destination. Then why I need to put unnecessary burden on the router? Lifetime will get reduced. You have the router which comes with the lakhs of the rupees. And just that you have done the CCNA and CCNP. Now you are expert in networking. You are saying, no, I will use all the routing protocol because I know all protocols. The router will not go. Router will say, no, I don't know you. Who are you? Router will simply go down. You cannot run all the protocol. You have to use the one or two protocol. That depends on your requirement. Right? So OSPF, AD value is what? Then this is for the routing selection, routing protocol. And in the routing table, we'll get 110 plus, let's suppose 1. Just an example. So this is your AD value. And this is your matrix. What is the matrix for the Opcom? And what is the matrix for OSPF? Opcom. So for OSPF, we have the matrix called cost. And here also lower will be preferred. That cost depends on the interface bandwidth. To calculate the cost of the OSPF, higher the cost, higher the bandwidth, lower the cost, and better the path. Higher the bandwidth, lower the cost, and better path. So that depends on the bandwidth. I have the 10 MB link, I have the 100 MB link, I have the 1 GB link, I have the 10 GB link, right? So write down first, take your time. Write down about the OSPF. Okay. In OSPF, higher the cost, higher the bandwidth, lower the cost, and better path. It means if I have the router, PC1, PC2, R1, R2, R3. If I am running OSPF here, then what is the criteria to select the matrix? Equal to cost, and cost equal to add the bandwidth and lower the cost and better path. Let's suppose from this link I have the 100 MB link, and from the here I have the 1 GB link, and here 10 MB. Right? Assume, actually there is a formula for cost, the interface bandwidth divided by reference bandwidth. Let's assume, when we discuss the OSPF, right, we'll explain everything. Let's assume here the cost is 10, here is 1, here is 100. So from source to destination, from PC1 to PC2, I have a two path. One is from PC1 to R1, then R2, then PC2. Another is from PC1 to R1, R3, then PC R2, R3, R2, then PC2. So from here, from source to destination, the cost is 10. From here, from the lower path, 100 plus 1, cost is 101. In that case also, the lower will be preferred. So from which path we have the lower cost? From the upper path, right? So this path will be preferred over the lower path. If this link goes down, so automatically that will get removed, and this path from the downside it will come into the routing table. Right? So for OSPF, the criteria is, for all the dynamic routing protocol, the matrix is the criteria to select the best path. And for OSPF, that depends on the cost. Cost equal to, that formula is actually interface bandwidth divided by reference bandwidth, but add the bandwidth, lower the cost, and better path. So it calculates the total cost to reach to the destination. It's not that one interface bandwidth. It calculates the total cost. For RIP, the criteria is hop count, right? So the lower hop will be preferred over the higher. A hop is equal to router. From source to destination, how many routers are there into the path, that will be considered as a hop count into the RIP, right? Now, okay, we were discussing this thing, right? We started from here. When we run the multiple routing protocols, these are the challenges: memory utilization, CPU utilization, packet forwarding delay, ease of management, lifetime of the router reduced. And if we come here, in this topology, we have run the multiple routing protocol. We have the RIP routing protocol, static routing protocol, and OSPF, right? So out of these, which one will be preferred? This routing protocol running, out of it, right? We have this thing into the routing table. So which one will come as the best routing protocol? Static, because static is having lower AD value, 1, right? OSPF is having 110 and RIP is having 120. If I am not running RIP static routing protocol, then which one will be preferred? Right? So from static also we are reaching to the destination. From the OSPF also we are reaching to the destination. There is no use of running a multiple routing protocol, right? That is why we don't run the multiple routing protocol on the router. We run one or two routing protocol according to our requirement. We not run the multiple protocol, because that will create some problem. The problems are CPU utilization, memory utilization, packet forwarding delay, ease of management, and lifetime of the router will get reduced because of the multiple protocol. If I am processing a more data, my capacity is something else, but I am processing beyond my that. I definitely the router lifetime will get reduced. Here. So let's start the okay, dynamic routing protocol. Static. Okay, one thing actually. Come here. So we have the static routing protocol and dynamic. For dynamic, if I write RIP and OSPF, AD value is best path. What is the criteria for RIP to select the best path? Hop count. Here is the cost. But what about the static routing? Let's suppose in the same diagram, I have the one diagram here. PC, PC, PC1, PC2. From PC1 to PC2, this time is the small network. I don't want to use any dynamic routing protocol. I would go with the static routing protocol. Correct? So from R1 point of view, this is R1, this is R2, this is R3. This is 192.168.1.0/24, 192.168.2.0/24, 192.168.3.0/24, 4.0/24, 5.0/24. Clear? That is 192.168.4. Now from R1, if this PC wants to go to the 3.0, that here into the R1 routing table will have the entry. First is static. Connected is 192.168.1.2 via 0/0, 0/0, 0/1, 0/2, 0/1, 0/2, 0/0. Then another entry C 192.168.2.1 via directly connected, not via, so directly connected. Directly connected with the 0/0 and 0/1 as static. So from this router to reach to the 3.0, I have a two paths. One is via this guy, another is via this guy. So if I talk about the upper path, then to reach to the destination 192.168.3.0/24 via 2.2. Another static entry 192.168.3.0/24 via, this is 4.1 and 4.2. So via 4.2. One is via 4.2, another is via 4.4. From R2 point of view, we'll also have the entry C connected 192.168.2.2 0/0. C 192.168.3.1 gig 0/, this is 0/1, 0/0. Static entry to reach to the destination, which destination 1.0, 192.168.1.0/24 via upper path. What is the IP address? 2.1. Lower path 192.168.1.0/24 5. Correct? What is the AD value for what is the metric for what is the AD value for static? And metric for AD value is always 0. Sorry, not 0. AD value metric for static value, metric for static route, metric. It's a static entry, admin entry. You cannot make changes in that. In that criteria, in the here, in this particular case, selection goes on the AD value. So we need to manipulate the AD value, not the matrix. In the dynamic routing protocol, this best path selection criteria is depends on the matrix. But in static routing protocol, the best path selection criteria depends on the AD value. So the AD value, we need to specify the AD value when you put the static out, and lower is always preferred. Not clear? Clear? Not clear? Say something. Where is the diagram? Gone, huh? Sometimes we know too much, right? So you will forget about it. How much coming matrix? Matrix is one actually.